Yes, sir.
Yeah. So looking at the question, it says study the following triangle and complete the table below, right?
Yes.
You're given a triangle with, of course, 3 sides, because a triangle's got 3 sides. A, B, and C, right? And we're given 2 angles, alpha and beta.
Yes.
So I think you are supposed to complete this table. Right?
Yes.
So looking at the first row there, second column, they're asking us to find the opposite side of the angle beta, right? And this
Yes.
is the opposite side of the angle beta is A.
Small. Yes.
Let me do this. Okay. A.
Mm.
And let's continue with that row. The adjacent side of the angle beta, it's B, isn't it?
Yes. Yes.
Then the hypotenuse. The hypotenuse is same for both angles. In this case, just C,
Yes.
according to Pythagoras. And looking at the sine angle of the angle beta. In this case, we understand that sine is the ratio of the opposite to the hypotenuse of the triangle, isn't it?
Yes, sir.
So
Yes,
in
sir.
this case, the opposite of the angle beta is A. So in place of A is the ratio of the opposite to the hypotenuse, which is C in this case, right?
Yes.
Now we look at the fifth column, the cos angle of the angle beta, the cos ratio of the angle beta. In this case, it's cos. What is cos? Cos is the ratio of the adjacent, right,
Jeez.
to the hypotenuse.
Yes, sir.
In this case, the adjacent is B, right?
Yes, sir.
The hypotenuse C, right?
Yes,
Then
sir.
the tan. The tan is the ratio of the adjacent to the opposite to adjacent. In this case, the opposite is of beta. The opposite of beta is A. So it's A over the adjacent of beta, it's B in this case. Right? Great. Then let's move on to the second column. Alpha. The opposite of the angle alpha, in this case, it's B.
Yes.
Then the adjacent side of the angle alpha, it's A. The hypotenuse is the same, C. Then sine alpha. Sine alpha is the ratio of, remember the same thing, is the ratio of opposite to the hypotenuse. In this case, opposite of alpha, it's B. So it's B, and the hypotenuse is the same, C. Right? Now let's go on to cos. Cos is the ratio of the adjacent to the hypotenuse. So in this case, it should be an equal sign here. In this case, our adjacent is A, and our hypotenuse still remains the same, C, right?
Yes, sir.
Then tan alpha is the ratio of the opposite to the adjacent. In this case, the opposite is B. The opposite is B, and adjacent is A. Right. We're done with this first part. Anyone with a question, you can just raise your hand. I think there's an option to raise your hand there. right? Anyone with a question can just raise their hand. Let's continue to question 2. Consider the diagram below and indicate which one of the following expressions may be used to correctly find the angle beta in the drawing, right? So the angle beta in the drawing, you see beta is located in this corner of the triangle between side R and side Q, isn't it? It is opposite to side P.
Yes, sir. Yes, sir.
Yeah. So which expression may use correctly find the angle beta, right? The angle beta, okay, in this case we have x sine q over r, x sine r over q, x sine p over q, and x sine q over p. All right, but in this case, we know that sine beta, what is sine beta? According to the definition that we gave,
Hypotenuse.
sine is the opposite of hypotenuse. So in
Yes.
this case, sine beta is p over
P over Q.
right? So to find beta, okay, let me just write this down. So I'm saying sine beta is equal to P over Q, isn't it? So to find beta, x sine P over Q, right? So in this, just find which one is x sine P over Q. In this case, it's C, right? Okay.
Yes, sir.
All right. Those with questions, just raise your hand. Right. I can see there's an option for you to raise your hand there. Okay, let's continue. Question 3. A 3-meter ladder leans against the wall and makes an angle with the wall of 28 degrees, shown in the drawing. What is the height h above the ground where the ladder makes contact with the wall? So in this case, they're looking for that height h that is shown on the diagram there. We can all see it now.
Yes, sir.
The height h. So according to Pythagoras, we know that if this is our angle, this is our opposite, right?
Yes, sir.
And this is our adjacent. And this is our hypotenuse. Right?
Yes, sir.
So if it's like this, we can, what are we looking for here? In this case, we're looking for the adjacent, right? Because h is our adjacent. So how do we find adjacent given the hypotenuse? Because we're given the hypotenuse, right?
Yes.
Ladder is 3 meters. So in this case, the hypotenuse is 3 meters. This is equal to 3 meters. We understand that, right? According to a 3-meter ladder leans against the wall. So this is 3 meters. So in this case, you're given the hypotenuse, we're given the angle. We ought to find the adjacent. Right? So which trig are we going to use there?
Cos.
Cos, right? Why? Because remember, cos is the ratio of the adjacent to the hypotenuse, right? So in this case, if we have the cos,
sir.
Yes.
Right, you are not audible. Sorry, sir.
I was not audible.
Yes, sir.
I repeat this. Okay, let me
Sorry,
just
sir.
let me repeat this part. Can you hear me now?
Okay. Can hear you.
Okay, great. So I was saying we are given the hypotenuse and we're given the adjacent and the angle.
Yes, sir.
So we say the trig ratio that we're supposed to use here is cos.
Yes, sir.
Yes, exactly. So cos angle, I'm supposed to put, let me just put a phi, is equal to the ratio of adjacent to hypotenuse.
Yes.
So in this case, we have theta, we have hypotenuse. We can make adjacent subject. It becomes
Yes.
hypotenuse cos phi gives us adjacent, right?
Yes.
Okay. So now I substitute my hypotenuse, 3 cos the angle is 28, right?
Yes.
I get my adjacent. Let's just punch that into the calculator and see what we get. Okay, I'm getting 2.64. Is that what you're getting also?
Yes.
Okay.
Yes, sir.
2.65 actually,
Yes, sir.
if we round off. But look at the number of decimal places we have here.
Yes.
So we should round it off to 2.7, isn't it? This is the final answer. So we're looking at the number of significant figures that we have here.
Yes, sir.
Okay, sure. Okay, let's continue. Moving on to Cartesian and polar coordinates. Right. You're familiar with what Cartesian coordinates, right? Let's just recap that. Cartesian coordinates, it's some kind of a system that helps us to locate things in space, right?
Yes, sir.
Yes, it might be in one-dimensional space, two-dimensional space, three-dimensional space, right?
Yes.
So depending on the number of dimensions, there's the number of coordinates that you need, right? In one dimension, you just need one coordinate, just need one value. Two dimensions, three dimensions, three values. Right? Okay, so this is a two-dimensional sheet. If you look at point A is described by two
Yes, sir.
digits, x and y, right? Actually, two
Yes.
coordinates, x and y. Because it's a two-dimensional space, it is defined by the x and the y dimension, right?
Yes, sir.
If it was a 3D, with the z going in and out of the pair, then we're going to get an x represent the z value, right?
Yes, sir. Yes, sir.
Right. Then the polar coordinates. These Cartesian coordinates, they take two values, the x and the y. The polar coordinates, they take also two values, but in this case, they take the magnitude or the hypotenuse or the value, right?
Yes,
And
sir.
the angle at which that magnitude makes with the x-axis, Understand?
Yes.
The value is measured
Yes.
from the x-axis.
Yes.
So that's the polar coordinates. Now, let's look at some activities I think we had done. Oh, there's this part of converting polar coordinates to Cartesian coordinates. Okay. Now let's do this example. Find the polar coordinates corresponding to this Cartesian coordinate, isn't it?
Yes.
Let's look at this question. Okay, let me do this. Can you see a whiteboard there?
Yes, sir.
Okay. So I want to write down the Cartesian coordinates here. 0.25 and 1.50. Right?
Yes,
So
sir.
the Cartesian coordinates. The question is asking us to find the polar coordinate, right?
Yes, sir.
How do we find the polar coordinates? So the first thing to do is you draw your Cartesian plane. Sorry for the diagram. I'm using a mouse, so it's kind of changing.
Yes, sir.
So in this case, this is the x value, right?
Yes.
This is the x value, this is the y value. So the x value, just move 3.25, which is somewhere, okay, let me just extend this now. Somewhere here, right? Then
Yes.
the y value is 1.50, it's positive, so somewhere there. So somewhere there, right?
Yes.
So this would be where the point is located, isn't it?
Yes.
So to find the polar coordinates, this thing is somewhere here. To find the polar coordinates, we need to find this r,
Yes.
the displacement vector of this point from the origin. This is the origin,
Yes.
0, 0. And also this angle, theta, you see?
Yes.
How do we find those values? We know that we have this value, which is 1.5, right? And we have this
Yes.
value, which is 3.25.
4.25.
According to Pythagoras, it's easy to find this value, right? Because this is a right angle triangle. Understand?
Yes. Yes.
This is a right angle triangle, so it's quite easy to find r. So using Pythagoras theorem, r is equal to the square root of this value, 1.5 squared plus 3.25 squared. What
Yes.
do we get then? 1.5 squared plus 3.25 squared. I'm getting 3.58.
Yes.
Okay, 3.58. Was this thing given in meters or
It's meat.
was it it's meters, right? So
Yes.
like in meters. And the number of significant figures, they are good because both of them have got 3 significant figures, right?
Yes.
So these are R now. Now it's time to get the theta, right?
Yes.
In this case, we can use any trigonometric ratio.
Yes.
Any trigonometric ratio, isn't it?
Yes.
Okay, so now we need to find theta. So we can use any of the trig ratios. So in this case, I'm just choosing to use the tan. So it becomes arctan, right?
Yes.
Tan uses opposite and adjacent. In this case, arctan, the opposite is 1.5, the opposite of this theta.
Yes.
Over the adjacent, 3.25.
25.
What are we getting for angle theta? I'm getting 24.8.
Yes.
Okay. 24.8 degrees. Okay. So we're done with that example, right?
Yes.
Okay, let me move back. Okay. So I'm back to the learner guide. Can you see it?
No, sir, I can't see.
You can't see the learner guide. Okay.
Yes.
Can you see it now?
Yes, yes, yes.
Okay, sure. Are these the values that we got?
Yes, sir.
Okay, perfect. Let's continue. Oh, let's do this example here. Find the Cartesian coordinates corresponding to 4 and 53 degrees, right? Let's do this question here. I'm just going to do it here. So I have my Cartesian plane here. Can you see it?
Yes, sir.
Okay, and then there's 4. So this represents the
Radius.
magnitude R, right?
Yes.
So there's 4 here, and then there's an angle here.
53
degrees, right?
Yes.
So they want us to find the Cartesian coordinates, right? Which means they want us to find x, y, right?
Yes.
Cartesian coordinates. So in this case, this is our x and this is our y. You see? So it's quite easy again. In this case, we have a hypotenuse and we've got an angle. We can find, this is the adjacent, isn't it? This is opposite.
Yes.
So given the hypotenuse and you want to find the adjacent and the angle, which ratio do you use?
Cos.
Cos, isn't it?
Yes.
So in this case, we just use 4. Okay. Let me do it the other way. Where's the number here? Okay. So let's start by writing the ratio of cos. Cos is like, so this is cos is equal to adjacent, right?
Yes.
Of hypotenuse. So for us to be able to find the adjacent, it's hypotenuse
Cos theta.
cos theta.
Yes.
Right?
Yes.
Good enough. Then let's find the adjacent using this ratio. I'm just going to clear space here so that. Okay. So in this case, my adjacent, which is x, my adjacent, which is x, will be equal to 4 cos 53. Is that right?
Yes.
Okay, what do we get here? $2.4.
Yes.
Okay. Meters. Now to find the y, how do we find the y? Y is opposite,
Use
right?
sign.
In this case, we use
Yes.
sine. So this becomes 4
Yes.
sine 53. What are we getting for the value of y? I'm getting 3.2.
Yes, sir.
Okay, great. So our Cartesian coordinates become, we just need to replace these values here. Become $2.4 and 3.2, isn't it?
Yes, sir.
Okay, let's see. There we go. Okay. Now let's go on to activity 2.2. So they say draw the graph and find the polar coordinates corresponding to a point located at that and that, and also that and that, right?
Yes, sir.
So draw the graph, which means it's 1. Okay, let's draw that graph here. Right, there we go. There we go. And they say that the first Cartesian coordinates that we are given are 5 and 12, right? So you just move 5 steps here. So let me call this my 5 here. And then I move upwards to 12. Let me call this 12, right?
Yes, sir.
This is X and this is Y. So
Yes.
So they meet somewhere here. So this is my point here. Okay?
Yes, sir.
You can put a line just to represent exactly. Okay?
Oh, yes.
Now we go on to another coordinate that we're given, minus 3.25. Move minus 3.25 steps somewhere there. But minus 3.25 is less than 5, right?
Yes, sir.
There. Right. And then 1.5 is less than 3.25, which means it's somewhere here. There we go.
Oh, yes.
Yes. So now we're looking for, what are we looking for? What's the question? The polar coordinates, right? So
Yes.
find this angle. I'm gonna call it theta, and this angle I'm gonna call it phi. Right. This magnitude I'm gonna call it R1, and this one I'm gonna call it R2. Right.
Yes, sir.
R1 and R2. Okay, perfect.
Yes, sir.
You know this value here, it's 12, right?
Yeah.
Okay. So how do you find the hypotenuse given the adjacent and the opposite? According to Pythagoras, hypotenuse squared is equal to adjacent squared plus
Opposite square.
opposite squared. Right. I don't want to use much of my space. I just wanted to show you that this is how you find it. Oh, what did I do here? Okay, there's a line here. Okay. Now let's find the hypotenuse. I call it R1. So R1 is equal to the square root of 12 squared plus 5
squared.
What am I getting here? I'm getting 13.
Yes, sir.
Okay. Is it in meters? Yeah, it's in meters.
Yes.
13.0 meters. Let's find theta, right? Theta, we can use tan.
Yes, sir.
Right, so theta is arctan. Opposite, which is, in this case, the opposite is 12, right?
Yes, sir.
12 over 5. What are we getting? $67.
Yes.
67.4. 67.4 degrees.
Yes, sir.
Okay. Okay. So we're done with the polar coordinates of the first point. Let's write them properly now. It's 13.0, 67.4 degrees, right? This is the first part.
Yeah.
Now let's find R2. R2 is equal to square root of, in this case we have 3.25 and 1.5, right? Squared plus 1.5 squared, right? What are we getting here? $3.58. Is that what you're getting?
Yes, I'm getting 3.58.
3.58, right?
Yes.
Okay. 3.58
meters.
Okay. Now let's go to phi. Phi again, we use arctan. The opposite, it's what's the opposite here? This side, which is 1.5. Over adjacent, which is 3.25, right?
So it's negative 3.25.
No, it doesn't matter because Yeah, it doesn't matter.
Okay.
Because it will give us the value of this theta. Remember, I said this angle is theta. I'm gonna have to find this angle here. I'm gonna call it, I don't know what's this correct letter. Yeah, right? Is it clear?
Yes.
Let me
Yes.
use another color here. Okay.
Oh yes.
Yeah. Okay. So now we can, what's the value of this angle? Tan 1.5 over 3.25. It's 24.8, right? Like here.
Yes, sir.
It's 24.8. 24.8. 24.8 is fine, is this angle, but we need an angle measured from the x-axis. In this case, it will be, we subtract this angle from 180, right? To get this angle. So if you subtract this from 180, it becomes 180 minus.
Yes.
Get this, which is 180 minus 24.8. So get 154, right? 22. This is the angle here. Does it make sense? 154.2.
So you are cutting, say.
Is it the network, I think?
Yeah, ish.
Can you hear me now?
Yeah, yes, sir. Yes.
Okay, sure. So this is the angle that we get, 155.2, right?
Yeah, yes, sir.
Yeah, and magnitude of the line is 3.58. So in this case, I'm going to answer 3.58 meters and 155.2, right? Now let's move on to the next question, part B. Draw the graph and find the Cartesian coordinates corresponding to a point located at this value and this value. In this case, let's just be quick because we know what we're doing now, right?
Yes.
4.3. Those with questions, just raise your hand. And this angle is 216 degrees, right?
Yes.
Great. Find the Cartesian coordinates. I want us to find the y and the x, right? In this case, y is equal to 4.3 sine, right?
Yes.
Oh, sorry, I made a mistake here because there's the way I drew the angle is wrong.
It should be on the third quad.
Where is 216? Okay. Should be here, right?
Yes.
Yeah. Okay, great. So this is your y and this is your x.
Yes.
So 4.3 sine, you can just use the same angle. 216. What do we get? Getting negative 2.5.
Yes.
Actually 2.53 because you're looking at the number of significant figures here.
Oh, yes.
Then our x value 10. Our x value is, in this case, no, sorry.
It's still 4.40.
You on the first one. Okay, so x value 4.3. In this case, it's cos, right?
Yes.
What do we get? Negative 314. Negative
Yes.
48.
8.
So what's left is just to write them in Cartesian form, which is this and that x, y, right?
Yeah.
Okay, let's look at the second one. It's 10 and then the angle is 104. 104 is somewhere in here, right?
Yes.
10 there. This angle is 104 degrees. We do the same thing. Your y 10 sine 104 degrees. Your x 10 cos 104. Right. What do we get there?
Yes.
9.70. The other one negative 2.42. Is that what you get? Okay.
Yes.
Okay, let's move on. Scalars and vectors. What is a scalar quantity and what is a vector quantity? So a physical quantity which has only magnitude but no direction is a scalar quantity. For example, mass. I think you guys did this. I'm not gonna go through this. I'm just gonna go straight to the questions. Right?
Yes.
What time is your lecture finishing?
Let me check for you, sir.
Okay, as you do that, we can continue. Let's look at this example.
The lecture finishes at 10:25, sir.
10:25.
No, sir, at 9:40.
9:40.
9:40.
Yes, sir.
Oh, okay, 9:40. I guess so we still have like 40 minutes left, right?
Yes.
Okay.
It's Tuesday, right? It finishes at 10:25.
No, it's Wednesday today.
Ah, okay, sorry. My bad.
Thank you. Let's continue. We define the scalar. Let's define a vector. A vector quantity is, we see here, scalar is what?
Magnitude only.
That's a vector. Physical quantity which has both magnitude direction is called a vector, right? So let's list some examples here of scalar quantities and vector quantities. Let me just unmute a few. So I'm just gonna call your name, then you say the quantity, isn't it?
Yes.
Okay, so on the scalar quantity, I'll start with Mahlatsi Maloma. Can you give me one example for a scalar quantity here?
Times.
Time, okay. Okay, and 27722. Example of vector.
Yeah, velocity.
Velocity, okay. Tarin Monyela.
Temperature.
Okay. Who else? Suhail. I don't think you have an audio there. Okay, no, it's fine. It's just a few of you guys. Let's continue. Mahlatsi Maloma again, just give me Maloma, just give me another vector quantity here.
Displacement, sir.
Okay.
Can you hear me, sir?
Yeah, I can. Thank you. Just
okay. Yes.
Then 27722. 27722. Okay, I think you can't hear me. Okay, I'm just gonna finish off here. I have mass, and then other vector quantity of acceleration here, right?
Yes.
Okay, great. Let's continue. Okay, how would you describe the new position? Okay, the following example illustrates the motion of an object starting at point A and ending at point C, right? Where is point A?
Yes.
It should be point A, right?
Yes.
This point C, I think. Okay, Fig 2.1 below shows an object initially at position A, and a few seconds later, I think this is point B. It is position B. How would you describe the new position of the object with reference to the initial position A? How would you describe the new position of the object? So we're saying that a few seconds later it is position B, right?
Hmm.
How would you describe the new position of the object with reference to its initial position A? A scalar, a vector. Okay. So how would you describe the position of the object at point B as a scalar? Hmm? In this case, it's distance. So we just say that B is 8 kilometers away from A, isn't it?
Yes.
Exactly. The object has traveled 8 kilometers away from position B. Then as a vector, right? As a vector, it has traveled a displacement of 8 kilometers.
Yes.
Do you have anything that is telling us about the direction here? Nothing.
No.
Okay, we can just say due east or in the x direction. Positive x direction. Right? Because a vector has to have magnitude and direction. You get it?
Yes.
Okay. So how would you describe the final position C with reference to its initial position and its position at B as a scalar? Okay. How would you describe the final position C with reference to initial position and its position B? So as a scalar, the object had traveled 8 plus 7 as a scalar, right? Which is 15 kilometers, a distance of 15 kilometers from point A to C, right?
Yes.
With reference to position B, it has traveled 7 kilometers with reference to point B. So the distance is 7 kilometers. Now with a vector, as a vector, it's also 15 kilometers due, is this east or west? I don't know.
It's
Due east, right? Yeah, due east.
yes.
What else do we need to know? Yeah, I think that's all. And then with reference to point B, C with reference to point B, 7 kilometers due east again. Or in the x direction, positive x direction. Okay, so there's a definition of distance and displacement. Distance is actual path traveled by object between its initial and final position that consider direction. Displacement is the straight line path of an object's changing position in a specific direction, right? Okay, some examples of displacement. This is distance, right? So let's go on to activity 2.3 here. A car drives around a traffic circle of radius 26 meters from point A as shown in fig below. Determine the distance and displacement of the car at point B, right? I think Dr. Kesha went through this in the slides, right?
Yes.
Determine the distance and displacement of the car at point B. So we know that a car drives around the traffic circle of radius. So this is the radius, it's shown. So this is the radius, which means to get from here to the center, that's the radius in this case. This distance is 26, right?
Yep.
So I determine the distance and displacement of the car at point B. Right? If it's at point B, the distance is this circumference, right?
Yes.
So how do we find this distance? We know that the circumference of a circle is 2 pi r, right?
Yes.
So to find half, this is like half the circumference of the circle, right? This thing is directly
Yes.
to A. So we just divide by 2. It's becomes pi r, right?
Yes.
That would be this distance. So in this case, we just substitute the value. The value is pi times r, which is r is 26, right?
Yes.
Great. Wow, what value are we getting there? I'm getting 81.
Yes.
81.7.
0.7.
Right?
Yes.
Now they want the displacement. The displacement is this distance from here to there. In this case, the displacement is just the shortest distance from this point. And we know that this is 26. The other half is also 26, isn't it?
Yes.
So the total distance from this point to this point is 26 by 2, right?
52. Yes.
Which is 52.
Mm.
So this is distance, the displacement. It's 52 meters, right?
Yes.
Great. Now let's move on. What is the distance covered and displacement when the car comes back to the starting point, right? See how many questions I'm left with. Okay, just a few. Okay, let's move on. Well, determine the, okay, what is the distance covered and displacement when the car comes back to the starting point? So same, the car comes back to the starting point from A and comes back to the starting point, right? What is the distance? Distance covered is the total circumference in this case.
Yes.
So
Yes.
distance is equal to 2 pi
2
r.
pi r.
So it's just 87 by 2, so 81.7 by 2. Now let's just substitute the values here. 2 times pi times, what is r? 26, right?
26. Yes.
What am I getting here? I get 163.4.
Yes.
Okay, great. Now what is the displacement?
0.
The displacement is 0.
Yes.
Okay. 0. Since this object returned its original place.
Yes.
The definition, what's the definition of displacement? Displacement is a straight line path when objects change in position in a specific direction. So if the object returns to its original position, there's no straight line path
Yes.
from origin to the final position, isn't it? So that's it, 0. Let's move on to question number 2. A man walks 400 meters north along one side of a rectangular field and then 300 meters east along the other side. With reference to his starting point, determine his displacement, his distance and the displacement. So a man walks 400 meters north. So starting this point, he walks 400 meters north, right?
Yes.
This is 400. Along one side of the rectangular field, and then 300 east, right? 300 east, right? Along the other side with reference to his starting point. Determine his distance and the distance is what? Right? The path traveled, the path taken.
Yes.
That is 400 and 300, right?
Yes.
So distance it's 400 as 300, isn't it?
Yes.
What am I getting? 700.
700.
Is that correct?
Yes.
Okay, now the displacement. The displacement is from here to there. There's another color here. This is the displacement, right?
Yes.
This is the displacement. Okay.
Yeah.
So we can use Pythagoras theorem, right?
Yes.
Perfect. Because this is a right angle. So according to Pythagoras theorem, just square root of 400 squared plus 300 squared, right?
Yes.
What do I get there? Getting 500.
Yes.
Okay. So 500 meters. That's we're done with this question. Anyone with a question, just raise your hand. I'll see here. Okay, I see someone raising your hand. Desiree Tanya. What's the problem?
So I can't see anything.
You can't see.
Yeah, like it's black on the screen. I can just only hear, not see.
I think it's your network, right? Because I think everyone can see. Probably it's your network. But don't worry, I'm gonna post this video. I'm recording, so
Okay.
I post it in the group, right? Okay, let's continue. Okay, right. Assume that you walk straight back to his. Now, what will the total distance covered be, right? So now you see what is happening here. This guy, let me just use another color, blue, right? So this guy traveled this path, and now they're saying that he walks back. But now what? Assume that he walks straight back. You see, straight back. What does that mean? That means from this point, he walked straight back to the original point, isn't it?
Yes.
So he took the displacement path, right? So the total distance covered by this guy would be 200 plus 500 plus 300 plus this is 500, right?
Yes.
Yeah. So what would be the total distance? 7 plus 5 is 1,200 meters, right? So 1,200. You understand?
Yes, sir.
Okay, great. If there's anyone with a question, just raise your hand. Raise your hand. Okay. Okay, we're done with this one. Let's look at one that I sent to you yesterday. Group. We still have a few minutes. I'll just be quick with that one. Yeah, there we go. Can you all see this one?
Yes.
Okay, great. So okay, continue. The first question: rest and motion are relative. That's true or false? It's true. Why? They say an object at rest and an object in motion are both relative terms. The reason is, let me give you an example. When someone is in a bus, the bus is moving and you're seated in the bus, relative to someone who's in the bus, you're seated, you're stationary, not in motion, you're at rest. But relative to someone outside of the bus, moving, isn't it?
Yes.
So that's the reason why we say rest is also right. We can say that an object is at rest, but if we look at global scale, if you stand at the sun, then look at someone on Earth, that the Earth is rotating. But when we are talking about the people on Earth, we can see that, you know, if you look at your laptop right now, whatever gadget that you use, and you're placing it on a desk, right? It's not moving, isn't it?
Mm.
But for someone who's at the moon, they say that your everything that we have is moving, even the chair that you're sitting on right now, moving.
Yes.
Because the Earth is rotating about its axis, and also it's rotating about its axis. Understand?
Yes. Sir.
So rest and motion. Motion is actually a relative term used. If you start moving, and then there's something stationary, the building is stationary. Relative to the building, you're moving away from it. Get it?
Yes.
Yeah, and that's what they mean. So it's true. Yeah.
Yes.
Then displacement is a scalar quantity. Is it true or false?
False.
This one? False. Yeah?
Yes.
We need to answer this quickly. Okay, so in this case, it's true, right?
Yes.
Case it's a false, because displacement is a vector quantity with both magnitudes. Then which one of the following is not a vector quantity? Between velocity, force, energy, momentum. Energy, right? Perfect.
Yes.
Velocity is a vector quantity, both magnitude and direction. Force is both magnitude and direction, because it is a product of mass and acceleration. Acceleration is a vector quantity, mass is a scalar quantity. If you apply a vector quantity to scalar quantity, you get a vector quantity. Energy is not.
Yes.
Momentum is a vector quantity, is a mass. So in this case, it's C. Energy is no direction. Okay.
Yes.
Let's look at question number 4. The game runs once around the circular radius of 65 meters at a speed of 2 meters. Air displacement is. What is air displacement?
0.
0, exactly. The value is just there to confuse you. It's 0.
Yes.
Which of the following pairs are both scalar quantities with energy and force? Speed, mass, temperature and velocity. Volume and weight. Oh, there's an error there. Okay. This part should have been put out. Right. So which of these 4 is correct?
D.
It's D, right? Perfect.
Yes.
It's D. Then example 1, plot the points whose polar coordinates are given by 2 and over 4, right? Let's do that. These are polar coordinates, remember the question.
Yes.
In this case, this is 2 positive 2, and this angle is pi over 4. What is pi over 4? Pi is 180, right?
Mm.
Pi is 180. So pi over 4, it's 180 divided by 4, which is 45, right?
Yes.
Exactly. So this is 45 now. We need to find, they just say plot, right?
Yes, sir.
So this is correct. We are done. This is y, this is x. Let's plot this one. We have 3 and it's pi over 4 is -45. -45 is measured anti-clockwise, right?
Yes, sir.
Anti-clockwise. Again, it's 45 here. And this is 3. This is 1, this is 8, right?
Yes, sir.
So we're done with the second part. Now the third part. What is 7 pi over 4? It's 7 times 180, right? Divided by 4 is 315, right? This angle here, it's 315 degrees. Is that clear? What happened to can you all hear me? Okay, thank you. I don't know what happened to my guy who was responding here. Okay, so we're on part 3. I was saying that 7 pi over 4, it's 315. Is that correct? It seems like the only person who can respond here is 27722.
Yes, sir. It's 315.
Sure.
Sorry, sir. Why is pi 180?
In radians, pi is 180.
Oh, okay. All right.
Yeah. This is another unit of measuring angles. So pi it's 180. 2 pi it's 360. Understand?
Yes.
Okay, so you should read up on that. Okay, so if this, if you multiply 7 by 180 divided by 4, then you get 315. So 315 is in the 4th quadrant. Somewhere there. So the angle is here, which is 315 degrees. This is y, this is x, right? This is your point,
Yes.
and this is 3. Okay. You do the same thing with this one again. I think it's pretty easy again. Also plot the point. It's the same thing. Then convert the following given in polar coordinates to Cartesian coordinates. I think you guys can do this, right? I'm just gonna end the session here.
Right.
Any questions, just post in the group, right? Before
Okay. All right, sir.
before 6 p.m. today, right? Even allowance
All right.
before 6 p.m. I'll respond to them.
Okay.
Okay,
All right, sir. Thank you.
sure.